Unit 5.3, increasing and decreasing intervals. The first step is to find critical points, and when the slope of a function is positive, the function is increasing. When the slope of a function is negative, the function is decreasing. So example A is graph F, where these are the critical points, because on this table they're equal to 0, and anything that's increasing is going to be positive, anything decreasing is going to be negative. So if you look at value number 1, you can tell this line is going up, so f prime would be positive. Then we hit a critical point, and from there 3 would be going back down, so it's negative. Go back to our critical point, and from 5 and 6 keeps going up and up, so it's positive. Example B, f of x is 1/3 x cubed minus 9x. You gotta find the critical points first. So you take the derivative, x squared minus 9, simplifies down to x minus 3, x plus 3 equals 0, and you find that your critical points are negative 3 and 3. Plug them in, so negative 3 and 3 are going to be 0. And from then on, you can plug any value on the left side of negative 3, so any value smaller than negative 3. So I chose negative 10. Plug negative 10 in here and here to get negative 10 minus 3 is negative 13 times a negative 7, which is a negative times a negative, which gets you a positive. So negative 10 is actually increasing. You hit the critical point. A 0, because it's between both negative 3 and 3. 0 minus 3 is negative 3, and 0 plus 3 is 3. So a negative times a positive is going to be negative. 3 is 0, and 10 minus 3 is 7, times 10 plus 3, which is 13, is positive and positive. So you get it's increasing. And for the graphs of f prime that already start as f prime, all the increasing values are going to be on top of the x-axis. So literally about from like interval 3, negative 3 to like 1, union of like, let's say 6. And infinity is only going to be positive, and all these values down here are going to be negative.